Hi, this is Tom, amateur radio call sign N8FTY, and today we're going to have another meter review. This is the Uni T UT161D. It is a 6,000 count meter. I thought we were done with 6,000 count meters, but in my quest to find more meters that are third-party safety tested, I discovered this meter. So we have a couple of more 6,000 count meters we're going to review. And this is the first. Comes in a nice case. And it has, of course, the instructions. And it has a link to download more. I got this off of Amazon.com for $89.89. And I got it specifically from the Uni T Direct store. If you get it from the Uni T Direct store, you get an 18-month USA warranty. Definitely Uni T is targeting the US market now directly through Amazon. There's a lot of imitators, so if you buy it from some other store on Amazon, they won't honor the warranty. You have to do it through Uni T Direct. So it's a tiny bit heavier than the what I call the cheap Chinese meters. So that's a good sign. It comes with gold-plated probes, but it's still, I would call that a little firm on the coating, so they're really not silicone. Comes with a thermocouple. It comes with its own screwdriver, so you can put in the batteries or take them out without having to have any extra tools. It also comes with a USB optical coupler to the meter, so you can download free software from Uni T that is for this meter, and you can connect this to a Windows PC. It has, this is an adapter for the thermocoupler, which is kind of the biggest adapter I've ever seen, but it works. And that is pretty much it. That's all that comes with it. You can buy, optionally, for about $30 from Amazon at the Uni T Direct store, a Bluetooth interface. And this also plugs in the back of the meter like that. We'll go over that a little later, but and it's kind of just pressure fit, so now I don't want this to turn off in the middle of us testing it, so if you press the select button before you turn it on, it'll give you 3 beeps, and now the auto power off is suspended. Then you hold down the hold button for a couple of seconds and the backlight comes on. But it's not very bright. I'm going to try something new today. I'm going to give you my bottom line conclusion first, so that way you don't have to watch the whole video to find what I think. Here's what I think of this meter. It is the cheapest so far that I've found that is third-party safety tested. This is tested by ETL. And I can recommend this meter to people who want to spend the least amount of money for a safety tested meter. I personally would not use this meter because it beeps too much. Beep, beep. But most the cheap Chinese meters do that. And I don't know why. They like to hear the beeps, but they do. And the other thing is the backlight isn't bright enough. So that's why I wouldn't use it. But I would surely recommend it to anybody who wants to get a third-party safety tested meter that has microamps, milliamps, amps, millivolts, volts, capacitance, resistance, and this one even has, and this has temperature. So, in a 6,000 count meter, and it's is a little bit on the, it's on the less accurate side, but that's what you're going to get for the $89, almost $90. And it's again, if you buy it from the Uni T Direct store, you get 18-month warranty. Plus, you're buying it from Amazon, so you get the 30-day return that Amazon provides. So, yeah, I would, for a budget conscious, I would look at this meter for electronic projects. Now, there are some lots of other meters if you want to upgrade or go a little better, but I would say this would be the minimum. So now let's get into it. Let's go tell you what the features of this meter are. This is ETL tested for Canada and US. It's Cat 4, 600 volts. It's Cat 3, 1,000 volts. It's 6,000 count meter. Its basic DC accuracy is 0.5% plus 3. Has a 31 segment bar graph. It's true RMS. It does a min and a max function. It also has a relative or delta function. It comes with a K-type thermocouple. Of course, I didn't test that because I don't have an accurate way to test temperature. And low Z, which is a low impedance AC voltage, so you can avoid ghost voltages on AC. That's mostly an electrician's concern, but you may be doing something that may help. It comes with 4 AAA batteries, which we'll talk about that. And it's got an 18-month warranty if you get it from the Uni T Direct store on Amazon. So it's got a reasonable amount of features. Let's show you how it acts. Let's do a little voltage, DC volts. I'd like to point out that similar to the fluke meters that have AC and DC on the same detent of the rotary switch, it defaults to AC, which is a little annoying, but I guess if fluke does it, it's good enough for these guys. But I do like meters that default to the DC range first, because in most electronic projects, you're working with DC. So let's switch it to DC. We have a voltage source here that I measured on my Keithley DMM 6500 that came out as 2.5005, and this meter shows it as 2.498. And I'd say for the price of this meter, it's pretty good. That does meet its specs because it's 0.5%. Here the meter shows 4.997, and the Keithley measured this at 5.0009. So still pretty close for 0.5%. Now this is a 6,000 count meter. Since we went over 6,000, it shifted to the right one and we lost one digit of precision. So this reads 7.49. The Keithley measured it at 7.5016. Again, that's within the 0.5%. Here we go with 9.99, and the Keithley measured this as 10.0015. This is just a reminder that we have a written review. The URL is in the description, so it has all the details. Some of the details I may skip here, or there's a lot of measurements I made, lots of numbers, lots of comparisons, so if you want to dig into all that detail, it'll be there. Now let's talk about the accuracy of the DC volts based on my testing. As you can see, the meter met its specifications in the manual for all the DC voltage measurements that I took. And that's pretty good for a $90 meter that is third-party safety tested. The input impedance was 11 mega ohms for the voltage range, and it was 13 mega ohms for the millivolts range. That's also very good. Okay, now we're going to move on to AC voltage. So I'm just going to show you an AC voltage off of the DMM check. If you have more than 1 meter in your house and you want to check it out, I recommend getting the DMM check. That's one of the things that got me started on this whole meter comparison. Of course, now I use some of my own boards that I made, but still for AC 100 hertz signal, this is a very nice reference. It also has a 5-volt DC reference. It also has AC and DC current references. And it has some resistors, capacitors that they give you a sheet with this that tell you exactly what they measured with a 8.5-digit meter. And you know, those 8.5-digit meters are about $15,000. So it's well worth buying this instead. And you can send it back for a reasonable price and get it recalibrated, which is basically they just remeasure it and send you back the updated sheet of voltages, resistance, currents, capacitance measured with that meter. Today we're going to show one AC voltage from this DMM check device, which if you have more than 1 meter and you want to see how close they agree with each other, I definitely would get one of these DMM checks. I will put a link to it in the description, along with the link to the written review, which will list all the AC voltages I tested. But right now, we're just going to show you this. I already switched the meter to AC, and we get 4.951. And the voltage should be 4.9987, but that is very close, considering that the specifications for this meter it's 1% plus 5 digits for AC voltage. Speaking of that, let's look at all the other measurements. They all met the specifications as stated in the manual. Again, very good for a meter this price. The minus 3 dB cutoff was 2.9 kilohertz. So again, that's respectable for this price meter. Now we're going to look at some AC milliamps, and then we'll go look at some DC. Here is 100 hertz AC current. That is 0.999652, and we get 0.99. So you can't beat that. For a 6,000 count meter, we're doing all right. Now we're going to measure some DC current. When you switch to one of the 3 current modes, the amps, milliamps, and microamps, it defaults to DC, unlike the voltage modes, which default to AC. So it's a little inconsistency there. We're going to start out with our 0.89 microamps. And the meter shows it as 0.9. And you can't blame it for rounding up. So no problem there. The next current is 9.21 microamps. And it shows it as 9.2. Another very good reading. Here's 99 microamps, and it shows it as 98.9. Again, very, very close. And it's much better than its specification. Here's 131.8 microamps, and we get 131.7. Again, for a $90 meter, pretty good. Here's 1.0 milliamps. And the meter reads 1.00. Can't beat that. Here is 9.98 milliamps. And we get 9.99. Very close. Very good. Here's 99.4 milliamps. And we get 99.4. Well, let's look at the specifications of current. And the meter met all its specifications in the manual with all the current I tried, which is very interesting because in general the AC current was 1.5% plus 5, but you see how close we got it. And the DC current is 1% plus 2, and we still was way closer than that. So I think it's this sample of the meter is very good. Meets the specifications and exceeds them. Now you have to be careful when you buy a meter, because you can't expect the manufacturer to repair it if it meets its specifications. So even though this meter is excellent, you could get another copy that is not as good, and if it still meets the specifications, then there's really nothing they'll do about it. I mentioned that I measured the shunt resistance for the amps is 0.02 ohms. For the milliamps, it's 1.92 ohms. And for the microamps, it's 100.88 ohms. Now we're going to measure some resistance. Let's short out the leads. Plug it into the right place. Well, it is mysterious, but it says these leads have no resistance, which I know isn't true, but we're going to go by what the meter says. This is a 1.004 ohm resistor, and it reads it as 1.1. This is a 10.007 resistor, and it reads it as 10.0, which is pretty good. Here is a 100.069 ohm resistor, and it reads it as 99.7. Little low, but it's within its specifications. This is a 1.0001 kilo ohm resistor, and this reads it at 0.999 kilo ohms. So again, it's just a teeny bit low, but definitely within spec. Here is a 10.002 kilo ohm resistor, and it reads it as 9.99. So it seems to be consistently a little on the low side, but again, well within the specifications. Here is a 100.02 kilo ohm resistor, and it reads it as 99.9 kilo ohms. Still a itsy bitsy low. Here is a 0.9970 mega ohm resistor, and we read 0.992. Here's a 9.97 mega ohm resistor, and it reads it as 9.8. Dancing around. 9.95. Again, a little bit on the low side, but within specifications. Here's a look at the resistance measurements that I made earlier, and they all meet the specifications. Note that it's 1.2% plus 2, so it's pretty wide. So all these readings were much closer than that. And again, it's sample variation, and this samples are really good. It uses about, on the low range, about 1 volt, and on the high range, it uses about a half a volt. Now it's time for checking some diodes. And our favorite diodes, of course, are LEDs. It lights up the red one, and it also did a little chirp to let you know that it is okay. So let's let you hear that little chirp again. Well, that's pretty nice. So you don't have to actually look at the meter to make sure the diode's okay. And other meters that do that, I've never seen it do it with an LED because the forward voltage is too high to trigger its little beep. But this one, LEDs trigger it. Here is the yellow LED, and it's lit pretty good. Here is the green LED. It's dimmer, which is the case with many meters, but it still did the little chirp. Very nice. Here's the Schottky diode, and it chirps also. Here's the small signal diode, and it chirped. Here's the rectifier diode, and it chirped with that also. Just for grins, we're going to wire it up backwards and see what happens. As expected, P infinity. Let's short it together and see if it chirps. It beeps. So if your diode is shorted, it'll give a continuous beep. The maximum diode test voltage was 3.26 volts, and the maximum test current was 1.04 milliamps. Speaking of continuous beep, it's time for continuity. For continuity, I use the ProbeMaster probes. Now I know some people have asked, why don't I use the probes that come with the meter? And my usual answer is I'm testing the meter, not the probes. So some meters come with good probes, some not. It's really up to your preference what you want to do, but I really want the meter comparisons rather than the probe comparisons. For probe comparisons, I don't know. I'm sure there's some good Chinese knockoffs that probably work just as good as these, but I'm going with these. It's generally, if you get it without the accessories, it's like 30 bucks, and I think if you get the accessories, which I did, it's about 40 bucks. But they're pretty good. All right, we're in continuity mode. All right, it's latched, but it does this weird pause. So when you touch it and leave it, it'll beep, then have some quiet, and then it'll start beeping again. And I think that is, actually that's confusing, because how do you know that's the pause? Well, with me, I work with so many different meters. I imagine I get used to that with this, but no, I don't really like that. But it is latched. Let's see how fast it'll go. Well, you can go fast enough where it just continuously beeps. And you notice it beeps, then it goes red, and then it goes green and beeps. So that's too weird. Too weird and too not normal. So that could be a deal breaker for this meter if you're really use the continuity a lot, and especially if you use it without looking at the meter. So that's disappointing, but again, it's a $90 meter. I can tell you that from testing, I have a $128 version of this meter, which is a 2200 count, and it does not have the same continuity glitch. I would call this a continuity glitch. Anyway, but if this works for you, that's great. But I think for many people who may use a lot of continuity stuff, this could be annoying. Well, now we're going to do some capacitor measurements. In the capacitance mode, the smallest resolution is 10 picofarads. And as you can see, there's some lead capacitance, which we will attempt to zero out with the rail button. All right. Now, here's my capacitance board, and I've changed my process. I used to measure these two ceramic capacitors. One's at 10 picofarad and the other is at 100. And I found that almost every meter has a problem, and it just doesn't measure it very accurately. The meters that do are LCR meters. So I'm going to stop including data on the 10 and 100 picofarad capacitor. I'm not even going to measure it anymore, because these general purpose multimeters are not meant to measure capacitance that low. Here's a 1.005 nanofarad capacitor, and it reads it as 1.03. So that's pretty good. Here's a 9.921 nanofarad capacitor, and it reads it as 10.07. That's within specifications. Here's a 99.51 nanofarad capacitor, and it's 99.9. Here's a 1.009 microfarad capacitor, and it reads it as 9.74. Oops. It reads it at 0.974. So far, these readings have been a little on the low side. Here's a 10.294 microfarad capacitor, and it's 10.7. It can't make up its mind. But this is an electrolytic capacitor. Here's a 112.2 microfarad capacitor, and it reads it at 112.8. Here's a 944.5 microfarad capacitor. Okay, the meter's switched up to millifarads, and it's 0.995 millifarads, which is equivalent to 995 microfarads. I want to make a note that the meter stayed in delta mode and still could auto range. That is unusual. There are very few meters I've tested that can do that. All right, let's look at the capacitance, and it met its specifications. You do notice that some of the specifications, as the capacitance gets higher, the specifications get less stringent, but that's typical of most meters. So this isn't bad for a $90 meter. Let's check out the accuracy specifications compared to other meters that I've tested. This is a set of meters I selected to do a presentation for an amateur radio club. I tried to tailor it to the more economical end. As you can see, of all the meters I tested in this group, the Unity had the lowest specifications. Again, we saw with this particular copy of the meter, it performed way better, but it still is the lowest specified, which I think for most people who are doing casual projects, I still think it's pretty accurate enough. And if you're lucky, you'll get one as good as the one I got. You notice to get into more accurate meters, you definitely have to spend more money. But again, as you saw with these measurements, even though the accuracy specifications are pretty wide, this meter was fairly close in the samples we did. Way closer than the specifications indicate. So that's a dilemma. Well, as you can see here, for the voltage and current, the specifications in general are lower than most of the meters in this group. The yellow indicates the lowest specification. The green indicates the highest specification. And as you can see, the green all kind of falls over to the expensive meters. But if you want a basic meter that meets all the requirements for electronic projects, you would not go wrong with the UT161D. You could get the EV blog Bryman BM235, but that's another $25 higher. And as you can see, it does have a little higher specifications and everything. For the capacitance and resistance measurements, you can see that the 6,000 count Unity is the lowest in many cases. This meter will do logging to a PC. If you buy the optional $30 Bluetooth adapter, you can talk to it with your Android or iOS device. It is nice that they include the USB adapter, which is optically isolated to the meter. I ran the software on Windows 10, and it worked fine. As you can see here, I did buy the optional Bluetooth adapter, and you can see it working here on my tablet. Now we're going to talk about the batteries. Let's turn it off. And there's one screw, which is in this little hole. You loosen that screw and this lifts out. And it's a captive screw, so you won't lose it, because I lose screws. It has 4 AAA batteries, and as you can see, the fuses are accessible. So you can't beat that. I really like the meters where they make the fuses accessible in the battery compartment. And they give you a screwdriver, so you don't have to look for one. All right. All right, let's look at the pros and cons of this meter. This meter is third-party safety tested by ETL. It's under $100, and it has all the basic functions you need for electronic projects. All the measurements taken met the accuracy specifications as stated in the manual. It includes a USB interface with free software you can download from the Unity site. It has an optional Bluetooth adapter that lets you talk to the device with iOS and Android. The cons of this device: dim backlight, unusual continuity behavior, beeps every time you move the rotary switch. Most ranges have the lowest accuracy specifications in the group, but it is the lowest cost meter in the group. What do I think of this meter? Well, the reason I will probably sell this meter is I don't like it that it beeps every time you change the rotary dial. I don't like the way the continuity function has that kind of weird on-off thing, which we showed, and I don't like the backlight. It's not bright enough for me. And that's the only thing I could find really wrong with this meter. I mean, this meter met all its specifications. You can hold the select down when you turn it on, and it bypasses the auto power off, and it also bypasses the auto backlight off. So that I appreciate. It met all its specifications, which I think I mentioned that already, but it is impressive for this meter. Unlike more higher priced meters, which I reviewed, this includes a USB interface, and it uses Windows software. I wish it used Mac software, but nobody supports that on multimeters. At least I haven't found anything. The best you get is it may work if you run parallels. And I've used the Unity software on parallels on the Mac, and I've used it on a bare metal Windows machine, and it all works. The other thing is you can buy a very economical Bluetooth adapter, $30. I don't even want to tell you how much the Fluke adapter costs to go Bluetooth on the meters it can do. But and there's a lot more expensive meters that don't have any kind of interface. So that's good. So all around, this is a pretty good meter for the price. And I think that if you're a beginner or you have an old analog meter, which sometimes you can't beat those VTVMs for doing work on boat anchors. But, you know, most people don't play with boat anchors anymore, and we have the nice solid-state gear. And a lot of our projects are all going to be in the, 12-volt, 6-volt, 5-volt range. This is great. So that wraps it up. This is Tom, N8FDY, saying 73, and take it easy.